I'd now like to look at two common questions where you're asked to calculate the domain and range of a function. So let's look at question A first. We've got y equals x squared plus 1. Now the domain, don't forget, are all possible x values, and you can look at this here and say, well, there's no real restriction on what values x can take. So we can say the domain are all, I'll use the word real x values. Another way of writing that is that x will be somewhere between minus infinity and positive infinity. Now, I might just indicate here what we mean by real. When we look at our number system, one way of looking at it is that we've got we can classify the first real subdivision of our number system into two basically families: the real numbers and the imaginary numbers. Now, imaginary numbers we're going to meet in later maths courses. Imaginary numbers are the square root of negative numbers. That's one example of what an imaginary number is, a square root of negative. So they fall into this category. Now, real numbers are like everything else. So you've got your fractions, you've got your negative numbers, you've got the number 0, you've got decimals. So real numbers are all everything other than the imaginary numbers. So when we use the word real, we are saying that all numbers that fall into that category, if you like. And another way of writing that is from negative infinity. Now, we don't put less than or equal to. We don't use that when we use infinity. Infinity is a concept, and it is x is less than negative infinity up to positive infinity. So that's the domain value. There's no real restriction. And if we look at the y values, which are the range, and if we have a look at what's going on here, we're actually getting an x value, we're squaring it. So we're going to get a positive number when we square it. So even if x is a negative, x squared is going to be a positive. Now, the smallest value that this can take will be 0 when x is equal to 0. And then we've got to add 1. So given that x is equal to 0, 1 will be the smallest value in the range. So we've got y is greater than or equal to 1 would be the range. So all values above that. Y can't equal 0. There's no value you're going to get there to be negative 1, because negative 1 plus 1 would be 0. So the smallest value that y can take will be equal to 1. If you are good with graphing, as we said in previous work, that this is just one way of expressing a function. Another way is to graph it. You know that y equals x squared, looks like that, and so that's y equals x squared, and we've got here y equals x squared plus 1. So all the plus 1 does is move the y equals x squared 1 unit up there, so that's 1. And if we look at that now, so this is y equals x squared plus 1, we can see that the smallest y value will be 1. So y has got to be a value further up there. And we also can see that x, this will go on indefinitely. It doesn't actually ever come back on itself. It actually continues opening out ever so small as we go further up. So x will go from minus infinity up to positive infinity. So there's the domain. X is greater than negative infinity but less than infinity, and y is greater than or equal to 1. So if you're good with your graphing, you can actually do that one as well. All right, so let's look at B. We've got y equals the square root of x minus 5. Now, we are not considering a square root of negative numbers, so we're only looking at real values. So we don't want x minus 5 to be negative. So we know that x, so for a domain, all possible x values, we know that if this gets less than 0, we're in trouble because we can't find the square root of negatives in the real number system. So we've got to say that x is greater than or equal to positive 5. So all values of x greater than or equal to 5. 5 will give us 0, and you can find the square root of 0, which is 0, so 5 is okay. But obviously anything bigger than 5 will make that a positive, and you can then find the square root of that. The range. Now we already said that if we've got x is equal to 5, we've got the square root of 5 minus 5, 0. Square root of 0 is 0. And anything greater than 5, this is going to be a positive number. Square root of a positive will give us a number bigger than 0. So that means that our range, y, can be greater than or equal to 0. All right. If we're good with our graphing, how do we graph this? What does it look like? Y equals the square root of x. Now we've got y equals x squared. If we were to square both sides here, we'll get y squared equals x minus 5. And what that does is it moves. If we've got y squared equals x, that will look like that. It actually, rather than being like that, y squared equals x, don't forget that's y equals x squared, but y squared equals x, it looks like that. What's the effect of putting negative 5 there? Well, the effect of putting negative 5 means it moves the graph that way. All right, so that's the 0.5. Now, we're saying, okay, we've got this area down here, but when we look at y equals the positive square root of x minus 5, we're only looking at that little bit up there. So, if you like, that is y equals square root of x minus 5, and this is y equals a negative square root of x minus 5. So that graph there can be split into two. Both those points there are 5. So this is the positive side. Now that's the one we're asked to find the domain and the range for. This, we're not asked to find the domain and the range. So if you like, we've got x is greater than or equal to 5, so that corresponds there. So all those values there of x are included on that graph there. And y is greater than or equal to 0 is all those values, all those y values going up there. Now this goes on up into infinity. All right, so once again, you can actually reason through there without doing the graphing and get you to the domain and range, or if you're good with your graphing and you should get better and better at this, that's another way of looking at domain and range as well.